So, hello, my name is Tetsuro Yamazaki from the University of Tokyo, Japan. Today, I will present about a design for code generators of safe Fluent interfaces. An important feature of that
Tetsuro, can
generators.
you speak? Excuse me. Can you speak a little bit louder because somehow the acoustics in the room. If you speak a
Okay,
little louder, then it will be better for
okay,
us.
I say I will try. So today I will present about a design for code generators of safe Fluent interfaces. An important feature of that generator is it supports two styles of method chaining. Uh, One is flat chaining style, and the other is subchaining style. So it enables programmers to mix both styles in their programs. So let's start from what a safe Fluent interface is. A Fluent interface is a library interface which is used by method chaining. Today, we can find libraries providing Fluent interfaces such as Stream interface in Java, or Juke, a Java library to access database by SQL-like method chaining. The right figure is an example of method chaining. This code calls a library function that accesses database and searches a column with its ID 123. I think you can read this program as if it is an SQL query. So the one good point of a Fluent interface is that it is a sort of DSL and well-defined Fluent interface that is the programs to be readable. We say a Fluent interface is safe when it detects incorrect chains and prevents execution of them. This detection can be done by type checking. We will show it later that how to make a type checker to detect such incorrect chains. Next, we'll look at method chaining in more detail. In most object-oriented programming languages, we can chain a method call just after another method call. So, for example, the method chain shown in the right upper figure, it first invokes the select method, which is static method defined in the SQL class, and then invokes the next from method. The point is the receiver of the from method is the return value of the first select method. And then it invokes the third method where the receiver is the result of from. So if the SQL class is defined as shown in the lower figure, all methods return the same class SQL, and the SQL class has every method appearing in the method chaining. So the chain passes type checking, and the resulting type is result. Note that receiver types are not necessarily the same. We can change the receiver types by changing the definition of classes. So a safe Fluent interface detects syntactically incorrect method chaining by type checking. This figure shows example invalid method chain. The where method cannot chain just next to the select method, and there must be from between them. And there also be two calls to from method that is not allowed in SQL. And we can make type checker to detect such invalid chains by setting each return type of methods based on which method can be changed the next. So, for example, only from method can be changed just after select. So by setting the return type of select to have only from method, this chain will be detected as type error uh, because there are no where method. So this is an example of implementation of such safe Fluent interface. By defining SQL class like this, the result of select method is instance of SQL2 class, which has only from. So receiver types transit like the right diagram, and the method only valid method chain type checks. And incorrect method chains are detected as type error because there are no corresponding method. So this transition of receiver types can be regarded as a simulation of an automaton using the type checker. The number of receiver types is finite, so the simulated automaton is a finite state automaton. And uh, so a safe Fluent interface by this design can check a protocol only when the set of valid method chains, which is a sort of language, is a regular language. Some methods, uh, some methods are proposed which simulates more sophisticated automaton and can check more complicated syntaxes. Since an advanced automaton uses a complex data structure in it, so we have to encode such data structure in receiver type to simulate such advanced automaton. For example, to simulate a push-down automaton, we encode stacks into receiver types, and to simulate Turing machines, we encode tapes to receiver types. So if there is a well-designed safe Fluent interface, programmers can easily write their program, can easily develop their software within it is readable. However, developing such an interface by hand is not realistic because a safe Fluent interface needs many classes, tens or hundreds of class definitions to encode such data structures like stack or tape. So a code generator is needed. Such code generator takes a grammar as its input. Since a Fluent interface checks its protocol based on the parsing technique, a protocol specification is very close to a language specification. The only difference between protocol specification and language specification is vocabulary. An alphabet in language specification is usually a lexical token, but an alphabet in Fluent interface is a method signature. The right figure shows a grammar for an SQL library. The epsilon denotes an empty string, and it says there must be methods must be ordered by select from where, and where can be omitted. So Fluent interface is usually generated from such a grammar specification. Then we consider how to support subchaining style. Subchaining is a style of method chaining. In subchaining style, programmers wrap out a part of the whole method chain as an independent subchain and attach it to base chain later. We say a method chain is flat when it is not subchain. The upper figure shows a method chain written in flat chaining style, and the lower one is in subchaining style. The highlighted method calls the part wrapped out. They are flatly chained in the upper figure, but in the lower figure, it is stored in the variable where and then attached to the base chain. So if programmers cannot write in subchaining style, their programs possibly become unnatural. For example, these programs are the same example to the first one. It searches a column with a condition depending on the variable negate. The upper figure is written in subchaining style, and it stores the search condition to the variable where and then attached to base chain. The lower figure is written in flat chaining style. Yes, we can write it in flat chaining style, but we need internal classes like SQL3 and SQL4, and we cannot change orders of method calls. I think it is not very natural. So our goal is to formalize a method to develop a safe Fluent interface generator that supports both styles. An interesting issue is the class of acceptable grammars. So from what grammar our method successfully generate an interface? If the grammar class is not clear, and if a library developer fails to generate an interface, then it is difficult to regenerate the library code. For example, there is an existing method by Nakamaru et al. It proposes a generator of safe Fluent interface supporting both flat and subchaining styles. However, the method possibly results in an incomplete interface, which may reject a flat chaining style method chaining, even if it is correct in protocol specification. So after finding a interface is incomplete, it is the only way to obtain a complete interface is try again and again, because we know there are some equivalent grammars, but we don't know from which grammar the method generates a complete interface. So we propose a design for generators of say Fluent interface supporting both flat and subchaining styles. Our method is very simple, so we can inspect what grammar it can accept. Our method generates a say Fluent interface by two steps. The first step rewrites the input grammar, and then the second step generates a library skeleton from the rewritten grammar. In the second code generation step, we use an existing generator to generate actual code. And note that this existing generator does not support subchaining style. It generates an interface only for subchaining style. So the first step embeds methods for subchaining style to the input grammar. So here we show the first step, how the first step writes the input grammar. For each non-terminal symbol, it just adds a terminal symbol to the right side of each production rule. Each added terminal symbols are unique, so they can be distinguished. Here is the example of in SQL. So the left figure is a grammar specification for SQL library, and the right figure is written. And method signatures highlighted in orange are the methods terminal symbols added by the rewriting. And the second step generates class definitions. The generation is separated in two parts for base chains and for subchains. The right figure shows a shellcode of the whole generation. The collision function denotes the existing method we use to generate actual code. And the first argument is the grammar, and the second argument is the stat symbol. What the set of valid method changes depending on which non-terminal symbol it corresponds to. So we repeat generating class definitions for each non-terminal symbol for subchains. So our method consists of two steps. The first steps, the second step is based on existing method, and we know it can accept all L1 grammars. Thus, if D, the grammar after rewritten, should be an L1 grammar. So the question is, what property G should hold to make FG an LL1 grammar? We worked on this question and we found some results. First, if G is not LL1, then G is not LL1. And if if G is LL1, if G is usually LL1, but there are some exceptional cases. And all exceptional cases appears only when there exists a non-terminal symbol such that it produces nothing or only empty string. And I want to show an exceptional case, but there is no time, so I skip. So, so this is summary. We proposed a design of say Fluent interface generator. An important feature is the generated interfaces support both flat and subchaining styles. And we revealed what grammar it can accept. So programmers, I think programmers can fix their grammar to obtain a complete interface. That's all. Thank you for listening.
Questions?
Thanks. All good. Hi. Thanks for the talk. At the earlier in the talk, you were mentioning that you think the only good way to sort of do this refinement of the Fluent design was by doing generation from a grammar. I was wondering what you think about, for example, like the idea of having like trait addition and subtraction being able to sort of also offer a similar thing while sort of being within the language without an extra DSLs, in a language like with traits and addition and subtraction of methods on them.
Sorry, can you say again?
What would you think about, for example, of like the SQL or the SQL thing you had was like a trait, and then you could basically just have the concept of trait addition and subtraction. You can add and subtract traits together. So you could just, for example, subtract the trait with the from the trait with the from method from the one with the from method, basically reducing it over time.
Subtract.
I might send you an email about it or something. Thank you.
Sorry.
So now actually I had a very different question. So I've actually coded in this style for quite many years now without knowing how it was called or considering having a generator. While it's true that you can get quite a lot of classes, they tend to be very small. So I just make them all nested classes and write on a single line. So even if there are 20 classes, they're like 20 lines. I think that the terminology that you're trying to introduce is possibly, a very big contribution in the sense that we need to learn to talk, about this kind of style. I was wondering, is there a difference between the flat style and the subchaining style in the expressive power? Because in the subchaining style, you are actually making an expression there, running code there, while in the flat style, you have all the knowledge from before. So if I'm imagining some stream-like version when your operation takes lambdas instead of strings, In the subchaining style, you have those lambda and you sort of probably going to execute them while you make your subchain, or at least that look like it's the most natural way of doing it. While in the flat solution, you have the information from before, and so you may choose to execute or not those lambdas. I fear my question doesn't really exist. I'm sorry.
So
I had it in my head, when I tried to.
I think the essential question was whether there is a difference in expressive power between the sub-chaining style and the flat one.
thank you for question. Uh, so the difference between expressive power of flat chaining and subchaining styles. Uh, so I think it is more difficult to analyze flat chaining styles. Subchaining styles are more easy to parse because the nesting structure is explicitly given by the programmer. So basically, expressive power. so so in either style, we can write any method called sequences. But the problem is, can we check it is really valid chain produced by the grammar? And if it is flat chaining style, we can use traditional parsing techniques. And if it is in subchaining styles, the parsing become more easier. More easier.
Okay, there's one more question there.
Thank you. Thank you for the nice talk. I've also used this style in programming, and I like it a lot. I use a DSL called Juke, and I'd like to know, one issue I have is when you select from, select comes before from, and then the columns unconstrained. So I want from the table, and then select only gives you the possibility to provide the columns in the table. So from should become, in your chaining style, from comes first, and then select, or if you have a nested expression, right, you only want those columns that are available in that context. So maybe I was wondering, is that possible in your DSL? Thank you.
So the question is, in my approach, the select and from methods can be swapped or not. I think there is our proposal is a way to generate a Fluent interface, and SQL is just an example. And we can, so our method can generate a library interface or not, depends on how complex the grammar is. And if it is L1 grammar, then our method can generate a interface.
Okay, let's thank Tetsuro one more time.